Hello everyone, starting a new project here today. Nothing huge, two little jobs. I'm doing a B44 Victor Special for a chap, sort of my very last commercial job, and he wanted this thing restored and just a couple of slight mods changed to it. One of the things was the original forks, which are the steel ones, are actually seized up, so he was going to have to do either a lot of work on them or replace them. So he decided to put something a little better in, and we talked about it, and I fitted the good old 4-stud ones that I use in the trial spikes to a couple of the B44 frames. So we decided to go with those, but he wanted to keep the original wheel. So we've got two jobs to do. One is we've got to make up a couple of pieces to fit the forks, because the obviously the old ones have cup and cone type ball bearings, and the newer forks have a tapered roller bearing, and naturally of course they're different sizes, so we're going to have to make up a couple of little sleeves to go into the headstock of the frame to take these forks. And then also of course the wheel is held in, this wheel is held in here with a through spindle that actually screws into one fork leg. And if you've got one of these, or you're getting one, this is left-hand thread. So don't spend hours trying to get it out the other way. Whereas, again, these forks, it's just a captive spindle that's clamped in with end caps. So we've got to make up a way of doing that. Now, unlike the trials bikes with the TY front wheel, which only has a 12mm spindle, which we can easily make up some pieces to fit into here, this is a much bigger spindle with different size bearings and all the rest of it. So I had to come up with something slightly different, and I got thinking about it, and it suddenly struck me, I wonder, you know, BSA, they like to utilise things, I wondered how close the two spindles were. Well, the width of the hubs is basically the same. So I thought, well, that's a good start. So I took one of the conical hubs and took the wheel spindle out of it, and it turns out that the wheel spindle from this on one side fits in perfectly because there's actually a sleeve. All I'm going to do is turn a little bit down on this and it goes straight into the bearing and its sleeve. On the other side, however, we've got to do something there. I looked and I found this is a 2-inch bearing. I can get a 2-inch bearing OD with an ID that will basically fit this. So I could go that way, or I can just simply make up another one of the small pieces that goes inside here. Another one of these sleeves for this side. So that's what I'm going to do. So there's the two jobs. We'll bring you in closer and show you this wheel and what we're planning to do there, because we're going to do the wheel first. Now I've got the bearing in this side of the wheel, and as you'll see, as I showed the other one, this was the main thing. I thought, okay, it doesn't quite fit. Well, it doesn't quite fit, it doesn't fit by a long way. But I could get a bearing with the right OD and the smaller ID to fit this. But then I remembered that there was this little thing here, because the hole in the brake plate is a lot bigger than the actual BSA spindle, the original spindle. So I thought, well, what's going on? Looked around and I found that there's this piece which is two different diameters. This first diameter here is correct for the bearing, and then this is correct for the brake plate, and it fits through there like so. And on this side would be the bearing. So I checked that with the conical hub spindle, and with a look at that, it goes on. What I've got to do is turn this down very slightly to make this a good tight fit, and then this will actually go in there like thus. So what I need to do is to turn this back so there's enough of the spindle sticking out the end to go in the forks. So I've measured that, and I need this to be further on here by, I think it's 1 5/16. I will check the measurement again before I set to. So the first thing I'm going to do is turn this piece here down to be a nice tight fit on this for 1 5/16. Then when this is in there, it'll stick through the brake plate enough for it to be the exact right fit in the end cap of the forks. Then we're going to make some measurements this side, make another one of these to fit on here, and then we can just simply put this wheel straight into the 4 stud forks, which makes things a lot easier. So first of all, let me go and turn this down, and then we'll check this back into the wheel. So there's the piece now fitted on there with enough of the wheel spindle sticking out to go into the fork. And actually I was wrong with my measurement, because I'd measured it 1 5/16 from here to there, but I'd actually only taken it to the end, so I actually had to take a little bit more off, because the original measurement was to the centre of this relief. Pardon me. The other thing is, on the conical hub, the brake is compressed with a large nut, which actually goes on this thread here. Because it's just a captive spindle, it just goes into the 2 end caps. But the spindle on here, on this wheel, of course, actually screws in. So when you screw it in tight, you're sort of holding the forks, and that's providing all the necessary pressure on the bearing in a race, so that the race clamps up and the bearing works as it should. So in this case, we're not going to have that clamping effect, nor are we going to have the nut on the end. So there are 2 end pieces that screw in here that will hold the bearings. Everything will be alright when it's finished. But because of that, I actually made this a press fit onto the spindle. Whereas originally it'll actually turn on there because it all gets clamped up. Here it's not going to get that force this way. So I've put it on nice and tight. So let's see if it actually works. So that now goes through there and sticks out considerably more. There's our brake plate going on. And there the studs, those narrow studs on the outside, fit perfectly onto the relief. And the same on the other side, which you can't see. So there we go, forks on there. Now the next thing to check, and I know this is slightly out from original measurements, is whether the wheel here is central in the forks. So let me zoom you out slightly. What we're going to do is we're going to measure from the mudguard mounting boss to the rim. And on this side it is 7/8. And on this side it's just on 1 inch. So we're out by 1/16. In other words, if we move the wheel 1/16 this way, then that will reduce the 1 inch measurement to 15/16, and it will add a 1/16 on the other side, so that 7/8 will become 15/16. Now what we could do is, there's a new rim going on here, is when we put the rim on we could make the offset slightly different, but actually we've got a little bit of space here on this piece, so what I'm going to do is just take 1/16 of an inch off that spacer that we've just put on there, that sleeve that's on there, and then that will move this to 1/16 of an inch. The wheel is exactly central, and voila, The other thing actually is that this brake arm here goes perfectly to the attachment on the fork. So what I thought was going to be a difficult job is turning out to be not too difficult at all. He's actually going to put 21-inch rim on this, alloy rim. Alright, so let's now move on to making some measurements on the other side to make another one of these sleeves. Before we go any further with this, who spotted the deliberate mistake? When I was doing the other side and I checked the wheel and the forks, I said we were what was it, a 1/16 of an inch out, so I could just take a little bit off that and allow it to move over rather than building it into the wheel. But of course I can't, because I actually measured to the relief in here, which is held in the forks at a particular place. So can't make any adjustment to this. When I build the wheel, I'm just going to have it that 1/16 over. Everything will be fine, but you should have spotted that and said. Anyway, I made another one of these pieces for this side. This is the OD for the bearing, and this is for the bearing to stop. So now we should have the right distance between the two inner bearing races. And the way I worked this out was simplicity itself. Straight edge to give me the famous datum, and then I measured down to the little step where the bearing sits. Measured that 1 5/16. Then I put this in and I measured to this collar here to see how far out we were, and then I was able to make this with an extra bit of collar on. So now when I put that in there, seat it in the bearing, put that across there. Of course you're not actually going to be able to see these, you're going to have to take my word for it, but when I go down to the collar there now, it's 1 5/16. Oops. So this centre stop here is exactly the same depth as the stop on for the outer diameter of the bearing. So that will now go in there. The other bearing will go on, and we can put it in our forks and everything will be right. And then, as I say, when I rebuild the wheel, we'll just make sure that we take that 16th into account with the offset. Right, so the next thing for us to do is the steering head bearings. And what we've got to do is we've got to go from this size outer race, which is the one, the cup for the cup and cone ball bearings, to this size race, which is the one for the tapered roller. So we're going to make a sleeve, and there's two ways you can do this. One is you can get yourself out of the scrap a nice big chunk of steel and whittle away at the inside and the outside. Or, slightly more expensive but a lot easier, is you buy yourself a piece of really thick walled DOM tube, drawn over mandrel. It's good quality steel, and what we've got here is that it is fractionally bigger than that, so a little bit of turning on the outside, and fractionally smaller than that, so we only need to bore a little bit out. And we just cut a couple of pieces. Well, what we'll do is we'll cut a piece about so long so that we can chuck it up in the lathe, and then we'll do the inside, and then we'll do the outside turning, and then we'll use a cut-off tool to cut two of them to length. So that's the next stage. Set up in the 4-jaw chuck. I've already taken the skim coat to zero our cross travel here. So the next thing we've got to do is measure what we want to be this OD here, which is going to be the same as the original cup that came out of there, which is 2.125. 2.125. So we'll make a note of that, look. So it's 2.125, and we are reading here at present 2.234. 2.234. 5 from 14 is 9. 3 from 3 is a 0. 109. Okay, so we'll take 100 off and then we'll measure it again. Let's see if we can take 40 thou off. Might have to get a bigger lathe. Right, let's see what we've got. $2.125. $2.125. All right, so we're okay for the OD, and we've got 1 3/8. We only need them to be about 5/8 in size, so 2 of those is 1 1/4. So we've got plenty of room to get in with our parting off tool. So, how observant are you? You may have noticed that I've had a rush of blood and bought myself a quick change tool post. So I must admit I do like it. So we're ready now. We've done the outside diameter of this to fit into the actual headstock of the frame. So now we've got to make it, bore it on the inside so that the new outer race for this, the taper roller bearing will go in to fit the other forks. So this is $1.781. 1.781. Let's write that down. Write that down, Michael, with a pen. There we go. 1.781 is what we're aiming for. There's already a pen there, look at that. And we are at present $1.744. 1.744. Yeah, 1.744. 1.744. That's 37 thou. 4 from 11 is 7. 5 from 8 is 3. Okay. Off there, and I said what, 37, it will take 30 off, remembering to go the right way because we're coming this way. 10, 20, 30. Use a slightly faster feed with it than that. We're on C there. All right. Let's see what we've got. One, 7, 7, 4. 1774. 774, that's 14. No, that's a 1, not a 6. 774, that's 7. Wow, because we said it was 37. Alright, let's take 7 off. 2, 4, 6, 7. This should be our final measurement. Fingers crossed anyway. .781 09. Very nice. So that's going to be a good tight fit. Excellent. Now what we're going to do next is put a chamfer on this, because where this goes down into the headstock, unlike the frame they've come out of, which goes down nice and square, when it gets to the bottom it actually has a little curve. Where is it? This outer race, the original outer race, has a little bit of a curve to the bottom, and it's going to allow this collar to slip a little bit further in, so we're going to do that. Isn't this clever? So we'll just do this freehand and then with a file. I'll let them cool down first before I touch them. Next thing is to use the cut-off tool to cut this off, but I've got to measure how deep we want it, so let's switch you off for a second. Now I've slowed the spindle speed down, put my cut-off tool in, and been and measured that, and we want to be 1/16. I'm taking it fractionally higher because I can always just grind the top off a little once it's pressed in. So, where's my other little... Lock the carriage down. There we go. Cooking oil on it. There we go. I hate parting. beautifully with aluminium, of course. Here we go. Chattering cut-off tool notwithstanding, which I'll have a little look at, make sure I've got it set right. That goes in there like thus. There we go. And that one is then going to go in there. Then goes that, and there we are. So let me do the bottom one and then we'll see about fitting the forks. There's the bottom race in and the top race. Hopefully you saw that. Just check we're still in camera and then we'll fit the forks. More or less. Boom, 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 boom. There's one. Let's use an old bearing. There. Alright, where's it gone? Yeah. I definitely took two of them out. There it is. And there we go. All nicely fitted in once it's got its little caps on. That's not actually working, that's the whole frame. Everything fits in nicely. So, there we go. Let's check again. Yep, you can more or less see what you're supposed to be seeing. So there we go. Later, 4 stud forks in the older frame. I have a friend who built a Victor scrambler for competition, and we put those in. And also I helped one lad build a 250 trials bike, and he had the earlier TR25W frame. So there we go. Now I'm going to move you up so you can see me, so I can tell you something. B44 is going to be a bit of an ongoing project, so I'll keep showing you bits and pieces of that as we go along. It's nothing special apart from that. It's just painting it, doing the motor and stuff. So as I say, I'll give you a few little views of it as we go along. And I have a couple of other projects coming up. But what I wanted to tell you was, the other thing that's coming up is winter in upstate New York. We've had our first couple of inches of snow. Fortunately it melted. But we've got more coming next week. And winter up here means, or can mean, a couple of feet of snow, maybe even more, and really cold temperatures. 2-3 months of below freezing temperatures. I have a little New Year's party every year when we ride. Never failed to ride yet. And then we have a party with our wives and everything. And we've had it here where we've actually had to dig out one section so that we had somewhere to ride for an hour. And another year when the chap who was taking photographs, his camera actually froze up. It was minus 12 degrees F. That's 44 degrees below freezing in F. What would that be in centigrade? Come on, Michael, your chemist, you should know. 44, 36, 45, it's nearly 5, 20, nearly minus 25, near as damn it, minus 25 degrees C. So we might get a bit hit and miss over the winter. I'm going to try and keep something coming up, but we'll see what we can do. So forewarned is forearmed. So until the next time, bye from upstate New York.